All right, so it is week 4, but only day 5 because we missed 2 Mondays this quarter so far. Hopefully we don't miss any more. I was a little worried that we might have a snow day, but since most people aren't driving anywhere, I'm not sure what the point of a snow day is. Anyway, we're going to continue playing with points and lines in a few different contexts today and the next day, and then for the share your work. Question? Oh, okay, and so we're just continuing the trend that we've been working on, and a big idea that I'm going to keep coming back to is the idea of slope, and that slope is a rate of change. And I want to be able to express in words what that rate of change means to somebody else, and why we might want to know that. The other things we're going to be playing with are getting used to equations that look like this here, where we have these 2 variables, the input, the independent variable x, and then the output, the dependent variable y. And sometimes we'll use other letters for them, like t for time. And then we have these other 2 numbers here, m and b, m being that slope layer, and b being the starting point or y-intercept. So similar ideas to last time. Just going to extend a little bit. Let's see, the share your work from last week, I've graded half of those so far, and a third of you didn't turn it in yet. I need you to turn that in ASAP. If you need any help with it, let me know. I can help at the end of class a little, but I can't help too much because this is something you're supposed to do on your own. So I provided this graph here with these points, and I provided the spreadsheet in case you wanted to see what the numbers were to go with each point. So the spreadsheet was a Google sheet, and the main reason I gave it to you was so you would have these tuition values there. Otherwise, you could look at the graph and estimate them, which some people did, and that's fine too. A couple people wrote to me over the weekend and said when they opened this in Excel, the graph got all messed up. So I'm just gonna take a look at that right now for fun. Let's see, download Excel. And I have an older version of Excel, but it's not too old. So it should be pretty similar. All right, so they ended up all jumbled here. Notice the axis is a little, there's some weird stuff going on here. So some reason Google and Excel did not agree on how to do this. Anytime I have a graph that's just not right, let's enable editing. I just delete it and then try and fix it. I had a full page version of it over here, and that's equally messed up. So we're not going to ignore that. And I'll demonstrate this in a couple of other videos, and I already have some recordings of it. But if you ever want to make a graph of a table of numbers like this, the first step is to highlight the numbers and just let go of the mouse for a sec. So you get, and the titles are useful too. So I highlight the titles and the numbers. And in Excel, there's an insert option up at the top. And then on most versions of Excel, there's a recommended chart. So you can see what they recommend. Now, first they recommend this line chart here. That's not what I want. Here they have a line with points. So if you don't see the kind of chart you want, and I just wanted the points, then if you scoot over to all charts right here, so I was on recommended, I move over to all, what we're making when we plot points, that's called an XY scatter plot or just a scatter plot. It's got a couple different versions here, and that one looks like the one I had in Google Sheets. And so it did a nicer job there. So I'll continue to show you how to make graphs like this today and tomorrow, and I'll share videos whenever you want. So there's a better graph. So again, Microsoft, you know, they want people to buy their stuff. Google wants people to use their stuff. And often Microsoft and Google, when you move a file from one place to the other, work okay, but they don't always agree. And sometimes weird stuff happens. So if you are ever experiencing technical difficulties with something like that, be sure to shoot me a message and I'll do my best to help you out. Anyway, let's move that out of the way. The point here was to say, well, these points kind of line up, and I asked you to pick any two of these points here and estimate the line through them by finding a slope and trying to come up with a y-intercept. And people used a bunch of different points. Nobody did it exactly the same way as anyone else for the most part. But one thing I want to encourage you to do is for these share your works, after you submit yours, take a look at what some other people tried. Like if you're not Alex, see what Alex did. If you're not Natalie, check hers out or check out Joe's. Most people had attachments. This didn't have to be done in a spreadsheet, but half of you decided to do so anyway, which is totally cool. I think it's going to be beneficial if you have good spreadsheet skills leaving this class and leaving college. Peter tried to type all his up with a cute table there and some nice highlighting. Oh, and he even goes on to talk about BMCC in comparison. Cool, thank you, Peter. Yeah, and if you ever post something and then decide you want to add to it, just keep putting stuff in there. And so I don't mind you making more than one post here. And again, check out what other people did. See how it differs from yours, see if you get what they were doing. That's the reason I have this as a forum, so we can see what other people do. All right. So again, if you didn't submit yours, if you have questions about the way I graded yours, be sure to let me know. If I graded yours, you'll see you suddenly have a grade and then there'll be some comments about it. So check it out soon. All right, let's get to today's work. So today, we're in week 4. We finished the self-regulated learning stuff. I still have to grade your reflection piece, so I will do that, probably get to it by tomorrow. Today's a pretty packed day for me. Hopefully you did the prep, oops, over here for 3.5. We're gonna work on the lesson online, and I'm gonna give you some tips about some of the homework problems. So let's jump into lesson 3.5. And as usual, I'll work with you a little bit on some of these, and then I'm gonna split you guys into groups to compare answers to see how you're doing. So this overview video, I'm gonna come back and do some examples like that. So I'm gonna skip what's in there. Feel free to watch that. I look at a few different examples of things that line up, kind of. And the big things here, I'm gonna rewrite some of these notes, and then we're gonna take a look at them for Raj's problem here. So I'm going to get a screenshot of that. So I'm gonna jump over to question 2. And again, feel free to ask a question while I'm going through this. All right, so we're going to come back to Raj in a minute. We're going to put him down here. So we're playing with things that line up. And the best way to tell if things line up is to look at a graph. And so whenever possible, I'm going to try and look at a graph. Algebraically, if things line up, you're going to have an equation that looks something like this, where you're going to have these two variables. Maybe they're y and x. Maybe there's some other letters, like down here, they say to use w and t. The m is probably the most important part of this. That's what we call our rate of change. It's our slope. And slope is a change in your output divided by a change in the input. The input is sometimes referred to as the independent variable, and the output is the dependent variable. Sometimes these independent and dependent are interchangeable. Other times there's no other way to do it. Like time is independent. We can't control time. It keeps on flowing. So time is always going to be independent. When we have a pair of points, like on a graph, somebody says, hey, here's a point and here's a point, or maybe it's in a table, sometimes we'll call that one the first point, one the second point. The order really doesn't matter, but we'll say this x value is the first one, so we do an x with a little 1 next to it, and this y value is the first one, so it's a y with a little 1. And this would be the second one, so an x with a little 2 underneath, and a y with a little 2 underneath. And the change in the output is always subtract your y values. So we usually write the second y value minus the first one, and then the second x value minus the first one. So this is change, subtract, change, subtract. That's the change. The rate means to divide. So I find those changes and then I divide them. So that's the idea of slope. So let's take a look at Raj's problem here. And I mentioned last week and the week before, a lot of times when I have something like this with multiple pieces of information, I make a table. So we've got weights and weeks going on here for Raj. So I'm going to summarize this in a table. And the week, that's a time, that's going to be my x, my independent, and then the weight is going to be my dependent, my y. And again, I like to write x's and y's because in my head I have this y equals mx plus b. I might also make a note here that this is t for the variable here and w. So half a week he was 193.4, so they don't quite tell us where he started, but close. So half a week in, 193.4, and then 4 weeks after starting, so 4 weeks later, he's at 187.6. And I'm asked to find the slope and intercept. Now, sometimes the intercept is just given to us, and in our table, if we happen to have a 0 in the independent input column, then whatever comes over here is our value for b, but we weren't given that. So we're gonna have to find this later. But we can get the slope right away because we have enough information. So usually we take the second number first, and it's got to be the y's in the top. So for my slope, let's set up a fraction. It's going to be 187.6 minus 193.4. And then for the weeks, it's got to be the second one, and then the first one. So I got to make that calculation. So I need a calculator. Just give me a sec to get a calculator open. And I think I'll use Desmos today because it's such a cute calculator. And what do we have? 187. I'll show my calculator in just a second. 187.6 minus 193.4. I just have in a second screen so I can make sure I'm typing it right. All right, so I think I typed those right. 187.6 minus 193.4 over here. My calculator says that's negative 5.8. In the denominator, I have 4 minus a half, which should be 3.5, but it's always a good idea to double check on a calculator, even if you're pretty confident. Oops, button. Oh, it's in the other screen. All right, so enter for a new line. 4 minus 0.5 is my 3.5. And the last step is to divide those two. So what is negative 5.8? So negative over a positive should be a negative, right? Divided by 3.5. And I get this kind of messy number, 0.1657142857. Oh my gosh, lots of decimals there. Desmos is kind of nice because I can say, hey, what's that as a fraction? You know, it's not much better as a fraction, 58 over 35. I'm going to go back to this one right here. And I'm going to pick 3 decimal places for now and then double check what the problem says.
Well, the problem says to round it to 2.
2 decimal places. Thank you, Brenda, for letting me know
You're welcome.
that. So -166, I guess is what we would go to 2 decimal places.
Yep.
So, and I mentioned before, when I round, I usually make a wavy equal sign to let myself know later, my future self, that, hey, you rounded there. So there it is to 2 decimal places. Now, what happened here? Again, these numbers in the top, they're weight in pounds. And then the numbers in the bottom are weeks. So that 166 would be pounds per week. And sometimes I like to know that, and I'm gonna write a sentence for that in just a minute. But we want to find the equation. So next we got to go for B. Now, if we consider the equation we're going for, so our goal here is to try and find something that looks like this right here. We'll put the right letters in there in a minute. And I've just found M. I don't know what B is yet, but I've got several choices for X and Y over here that I could just plug in. So since I have those points, I can plug in M here, I can plug in X, I can plug in Y, and then I'll figure out what B is. So that's what I'm going to do next. So new page, Y equals MX plus B. And it doesn't really matter which one I pick. I'm going to go for the second one, I think. If X is 4, Y is 187.6. Sec. And welcome, Cody. I'm glad you could join us. We are working on question number 2 in the lesson. All right, so I lost track of what I was going to write. Wrong button. 187.6. All right. So Y is 187.6. M we just calculated to be about -1.66. And X, that was 4 weeks later, we had that weight. And once I plug in the X, the Y, and the M, I can now solve for B. So to do that, I got to make that calculation right there. So back to my calculator. What is -1.66 times 4? I get -6.64. And then to get rid of this negative number that's added here, I'm going to have to add it also to get rid of its negativeness, if that makes any sense. So -6.64 plus 6.64 is 0. 0 plus B is just B. So on this side, all that's going to be left is the B. Now I got to do the same thing on the other side. I got to add 6.64. And I feel pretty good about that. Without a calculator, that's going to be a 4, 6 and 6 is 12, 7, 8 and 6 is 14. I think it's 194.24. I'm going to double check on the calculator. All right, so enter. So now I have my 187.6 plus the 6.64 and 194.24. I think I did good. All right, so now we have the y-intercept there, the b, so now we can write down the equation. And again, they told me to use not a y, but a w, and not an x, but a t. So it looks like my equation is w equals -1.66 t plus 194.24. Sometimes I like to find a way to check to see if that's right. So if you wanted to check this right here, what you would do is plug in the other x value. So for example, up here, I used x equals 4. So to check this, I would plug in x equals 0.5 and see if I get the right y value. So I am going to try that. So I think if I take negative 1.66 times 0.5 weeks and add on that 194.24 there, 24, I should get the weight that was given to me, 193.41, and the original was 193.4. How come I didn't get exactly 193.4 like the problem gave me? I'm close. 193.41 versus the original 193.4. Any thoughts?
Is it because we rounded?
Yeah, it's because I rounded, and that stuff happens. So, you know, for 1/100th of a pound off, I'm good enough. Yeah, so because we rounded in the step with the slope over here, then answers after that are going to be a little off from the original two numbers, but close enough. So I think we're good. Sometimes people like to not use rounding until the very end. So the only way around that would be to, when I was playing, remember I was playing in Desmos and I said for the slope right here, I could use the fraction version of it. So if I used the fraction version, I wouldn't get any rounding error, but I would have a slightly different y-intercept. So just to demo that here, if I took the, let's see, what was it? 187.6. And I add to that, they say the slope was 58/45. And multiply by 4. So the only thing I'm doing different here, so this is comparable to these two steps up here, that one and that one. I'm going to get a slightly different y-intercept, 194.23.
That's what I got. I got it right.
Yeah, and for all these problems, there are slightly different rounding techniques you can use, and they're all close enough. So I have a couple of different options on how I can state my slope and how I state my y-intercept. They're going to be close, but not exactly the same. Right, 194.23 versus 194.24. Close enough. All right. So again, will people have slightly different answers on these things because of the rounding decisions they make? The answer is yes, and that's okay. All right, so there's a couple variations on the answer. This is the one I came up with right here for question number 2 in the lesson. And so hopefully you followed that along with me and it made pretty good sense, or plowed your own path there. Questions on this equation? Okay, so I'm just going to make a statement about what the slope in this situation means, because this is something that, one of the most important things in this whole month's worth of work that we're doing. Button, right button. So I want to interpret the slope here, which means just state what it means. So we did a calculation. We ended up with Raj's slope was negative 1.66. Now a slope has a numerator and denominator normally, but I did the division and lost the denominator. So I can always view that as negative 1.66 over 1. Okay, so if there isn't a denominator, put 1 in the denominator. Now my output in the top here, my output was pounds. And my input was the number of weeks that went by in the weight loss program. So whenever I want to interpret a slope, tell somebody else what it means, what I do is I write down the slope, I write it as a fraction, I remind myself what the numerator means, and I remind myself what the denominator means. The negative here would be a decrease in pounds, or a drop, something like that. So what I could say here is for the slope, Raj is losing, so there's my word for the decrease here, about 1.66 pounds per week. And this is on average, right? He's not losing exactly that much each day, but roughly. So I'm going to say on average. Because we looked at the fourth week, we look at the first half of a week, but we don't have any information what happened in between. We just kind of averaged it out when we did the subtractions and the division on this weight loss program. That would be my sense. I just want to put it in context. And I want to put enough information there that most people would just get it and they wouldn't need to ask me any questions like, what do you mean about any part of it? So I think I did okay there. All right, let's take a look at other stuff we're going to be doing. So there's another problem, number one, I'm going to leave that up to you guys to do, where you're given a pair of points and you want to find an equation. And the steps I went through are pretty similar. If you're given just two random points, then it goes like this. So to find a line through 2 points, the first step is to find the slope. The second step is to plug in one of the points, so a point, and the slope into y equals mx plus b, so that you can solve for b. So that's what we did with Raj's problem. We found the slope. We plugged in one of his points, the y value, the x value, and m, so that we could solve for b, and then finally we can state the full equation. I'm going to leave number one for you to do now or later. I'm going to jump over to the next page. So on the next page here, we are given some data about minimum wage. And this is minimum wage in Washington State from 2005 to 2015. And we're just going to see if we can find an equation through there. Now, if you look at these kind of line up. They're a little wiggly, not perfect line, but there's a pretty good line through those points there. Other things to note here, we're given the actual data here in a table, and I'm going to show you how to recreate this graph in a spreadsheet in just a minute. And then I'm going to skip over question 3 for a minute. In question 4, we're then asked to find an equation, and we're given some more details. So here it says find an equation for the linear model approximating the minimum wage data using the data values from 2005 and 2015. So they're telling me which 2 years to use. And then T here is going to be years after 2000. And I mentioned that last week for the share your work that it's nice to pick a convenient starting year. And here they're picking for me, use 2000. And in the share your work, people used a lot of different values like 2009 or 2010. Some people used 2000. There were many different options and they're all okay. So before I continue here, I'm just going to do a quick demo how to put this into a spreadsheet if you wanted to. So a lot of times you can just copy a table from a web page into someplace like Microsoft Excel or Google Sheets. Now, it is tricky a little bit though. When I copy this, I need to make sure I start right on the beginning of the word year. And when I end, I just got to go right to the edge of the last number. If you copy too much stuff and then try and paste it into a spreadsheet, the spreadsheet's going to get very confused on what to do with the other stuff. So the important thing about copying a table from a web page or another document into a spreadsheet is to just carefully select only the values in the table and no more. So then I can right click and copy, or Control C on the keyboard copies. And I've got Excel waiting for me here somewhere. There you are. Oops, that's the wrong one. Let's just get a new one going here. New blank spreadsheet. So I could just start with a new spreadsheet in Excel, and hopefully you can see this all right. Blow it up just a little bit. And you can paste it anywhere you want. I usually post it near the top. So I'm just going to go to cell A1, and to paste, it's just simply Control V on the keyboard, or you can right click, and paste. Here they give me the option to keep the formatting or just match wherever it's going. So it usually doesn't matter too much. That looks pretty. I'm just going to go with that right there. So it's in a spreadsheet now. So I could then do spreadsheet calculations here instead of doing them in a calculator. And so I'm going to do it both ways today. If I wanted to reproduce that graph here, like I showed before, whether you're using Excel or Pages, no, sorry, what's the Apple one? Numbers, or some other spreadsheet, the usual way to make a graph is to first highlight the data and then go to the place where you can insert a graph. In Excel, usually we want to go to recommended charts first and see if they pick the one we want. Now, I didn't want a line graph here. I wanted just points. So then I have to go over to all charts, and then I want to scatter. And then that doesn't look quite right, but I'm going to hope it does once I hit OK. Okay, it fixed itself. So there's that set of points. The only difference between my version of the graph and the one shown in the problem is that they started in year 2000. And the cool thing about that is I can kind of put a line on a piece of paper on the screen and kind of trace back to see what around where the y-intercept is going to be over here. And I'm going to do that in a minute on my page. Google works pretty similar. So if I brought up a new sheet, I should just be able to paste it in if I copied it right. Come on, Google. There you go. And pretty similar to Excel. And then if I highlight it, I can ask for a chart. And Google has a little chart button, or I could go to Insert Chart. Google automatically gives me a recommended chart. It picked a line graph. If I don't like it, on the side, I can go to the chart editor and I can pick something else, like a scatter chart. And now it looks a lot like the one that Microsoft Excel gave me. Okay, I might as well name this. All right, so what I want to do is I just want to play with this on a piece of paper. So I need a screenshot of this here. So I'm going to help you get started on this, and then I'll let you guys finish it. So the first thing I would do is if I don't have a printer at home, and I don't have a printer at home because mine died and I don't feel like buying a new one, I would just take a piece of paper and hold it up to the screen and see how a line looks through there. So I've got this little line tool here. I'm just going to go click on that point and drag it through. And my goal here was, since they told me to use the 2000, oops, it's not a pen, try it again. They told me to use the 2005 numbers and the 2015 numbers. When I drew my line, held up my piece of paper to the screen, I was aiming for that point and that point, because that's the 2015 and the 2005 numbers. And now, since they're saying T is years after 2000, this right here is my y-axis, and now I can estimate the y-intercept. So looking at that, I'm going to estimate that the y-intercept is about, I'm going to say 620. But I'll calculate it in a minute just to find out. So the nice thing about having a graph is you can look at the graph and play with it a little bit and estimate some things. Next thing we need to do is find the slope. So we need to figure out what's the rise here and what's the run here. Right, so this is what we call rise. That's our change in output. And this is what I call the run, which is also our change in our input. So I'm going to calculate those for slope here. Let's see, we have 947 minus 735 divided by, and for I could just put in 2015 and 2005, but if I put another row here for t, this would be 5 years after 2000, and this would be 15 years after 2000. So I could just do 15 minus 5 here, given my definition for t. And it's always a good idea to have that written down in front of you, just as a reminder, so you don't get that confused. So we need to make those calculations there. See what happens. Let's bring up Desmos again. So 947 and 735. Decimal point. 947 minus 735. And this decimal again. So my numerator is 2.12. My denominator I can pretty clearly see. Now with a nice calculator like this, you could do it all in one shot. So you could hit fraction, type 9.47 minus 7.35. And then in the denominator, I could do the 15 minus 5. And it makes the whole calculation for me. So the computer is claiming it's 0.212. Put that back in my notes. And I think it's a good idea. Anytime you use a calculator, write down what you did and then write down the results. So I had 2.12 divided by 10, which comes out to be 0.212. Reminder, what does that number mean? The top is money and the bottom is years. So this number right here would be dollars per year. So what this is telling me that on average from 2005 to 2015, minimum wage in Washington was going up by about 21 cents per year. We need to find the equation here. So next we need our y-intercept. And it doesn't matter which one I pick. So somebody help me out here. Should I pick 2005 as my starting point or 2015 to find the y-intercept? Hello, is anybody with me? Help me out here. 2005 or 2015? We'll just patiently wait for some input.
Well, 2005.
Thank you very much, Natalie, for participating in class today. All right, so 2005. So then I'm gonna go to a new page here. So in 2005, T is equal to 5, and the minimum wage was $7.35. Did I get that right? Yep, all right. We now think that the slope, M, is 0.212. So I'm just gonna plug that information into my y equals mx plus b, but I'm gonna use the w and the t here. And I double check that that's what they wanted me to use. W and T, all right. So W equals M times T plus B. My W is the 735. My M is 0.212. my t is 5, and now I can solve for b. So then I need to make that calculation there, and then I need to subtract it over to the other side. So I'm going to do that on my calculator. What is 7.35 minus 0.212 times 5? Calculator says it's 6.29. So we're kind of backwards predicting that if the trend from 2005 to 2015 was roughly linear for a while, then in the year 2000, minimum wage is about 6.29, is what we just predicted. So now I think my equation is W equals 0.212 T plus 629. And again, remember T was years after 2000. W is the minimum wage in Washington. Since we're doing years after 2000, this number right there is our estimate of the minimum wage in 2000. Because we're starting in the year 2000. And it's an estimate because we weren't given that. We had to calculate that. And so this is that process I mentioned. If we're given 2 points, then we first find the slope, and we plug in one of the points in the slope to estimate what the y-intercept should be, and then we have our equation. We just write down the whole thing. Okay, so up here, we're supposed to look at these red lines and say which one did a better job of going through the points. And interesting, those horizontal lines. This one only has what? 1, 2, it's between 4 lines. I guess that's this one right here. Yeah, so it looks like this one. They won't be in the same order on yours, unfortunately.
I picked 2 of them and I got it right.
Okay. Let's see, each of the lines was found using a pair of values. Which of the lines is a reasonable approximation? Yeah, so like this first one on mine, there's too many points below and none above. This one has too many below on the other side, but not above. And this one kind of almost hits a whole bunch of them.
Yep,
So
those are the 2 I picked.
yeah, so you could pick 2 there. All right, we got an equation there. Okay, so what does the slope tell us? And the y-intercept. So I'm going to let you guys think about that one, and then making the prediction. Whenever you make a prediction, you got to remind yourself about what your t is. And in our example, we're claiming t is years after 2000. So then when they say use the year 2020, then we have a little work to do to say, oh, what is t then? So for that later problem, if the year is 2020, t is years after, so t would be 2020 minus 2000, or just 20. Whenever we do a years after, if it's not obvious, you can always do a subtraction from the starting year. So we want to make sure we plug in 20 there to get that one. All right, next one wants us to make a prediction. All right, so what I'm going to do is I'm going to split you guys out into groups for about 10 minutes to double check some answers up to 7, and then we're going to reconvene to go over the next problem about a boy's height, because I want to emphasize a couple things about it, and then we'll regroup.